Hello, everyone, and welcome back to Lady Scientist Podcast. I'm your host, Jocelyn Pearl, and today we have another great conversation to share with you all. I chat with Lindsay Pino. She's one of the founders of Talus Bio, and she's part of this new wave of founder-led biotechs that's happening right now in this industry. It's a pretty exciting time. Before we go any further, if you've been enjoying our content so far, please hit subscribe and leave us a review on whatever platform you use to listen to podcasts. We really appreciate you supporting this independent show. I also want to give a shout out to our sponsor, Kendall Investor Relations. They are hiring currently, as is my startup company, Tune Therapeutics. I'll link our careers pages below if you're interested in working in the investor relations space or in the epigenome engineering space. There's a lot of opportunity right now, and it's a pretty exciting time for science. So I hope you enjoyed this interview with Lindsay Pino. So let's jump in. Welcome, Lindsay Pino, Dr. Lindsay Pino. Welcome to Lady Scientist Podcast. I'm so excited to chat with you today and learn about your scientific career journey and what led you to founding Talus Bio. So welcome to the podcast.
Yeah, thanks for having me. I've been really looking forward to chatting with you. It's exciting.
So let's jump in to Talus right away. So can you give us a little bit of background of what led you to co-founding this company?
Yeah, so Talus is a very early stage biotech that we spun out of some work when we were at University of Washington together. My co-founder, Alex Federation, and I had met in the lab working on this project. And then, I defended grad school. He left to go work in industry. And a couple of years later, it was kind of the right time, the right place, and we got back together to make Talus a thing, to launch the company.
Awesome. And what is the main technology that the company's focused on?
Yeah, so this collaboration that he and I were working on really brought together our two areas of expertise. So he was coming out of Harvard doing medicinal chemistry for his PhD. He was doing his postdoc in the same lab where I was doing my PhD. My PhD, my work is mostly analytical chemistry with some computational thrown in. I had kind of decided I wanted to go to grad school, learn how to code. It was like, it's like the cool thing to do these days. You got to learn how to code no matter what area of biology you're in. So I was in grad school to learn that. And this technology that we had come up with, Alex had this new method to get all of the proteins interacting with DNA into a sample. And then what he needed was a way to measure what those proteins were. First, like, what is their identity? Then second, how many of them were there? And it just so happened that was exactly what my PhD project was, is how can we measure all of the proteins in a sample, quantify how much of them are present, and do that in kind of an unbiased, really high throughput way. So he had these samples, I had this technique, and when you merged them together, it came up with this technology to measure all of the proteins interacting with DNA in a live cell.
Awesome. And when did you incorporate the company? When did you start the fundraising process? Give us a time frame for that.
Yeah, both of those were in the summer of last year, so we're just barely over a year old now. And it was kind of, at first, it was a little bit, we weren't sure if this was going to be a thing or not. So what had happened was we worked on this project together. We kind of both went our separate ways, but the paper on this technology was kind of under review and still going back and forth. Everybody knows that pain dealing with the reviewers. The paper finally came out. It was finally published and peer reviewed. That happened early 2020. And all of these scientists started reaching out to Alex and reaching out about how to get in touch with this technology. How could their samples be run using this technology? And it kind of reached a point where it was very clear there was a market for this kind of work. Like, people wanted this. So he reached out to me last summer. I was in the middle of a postdoc, had just started a postdoc in Philadelphia, pitched this idea, and we were kind of like, all right, let's do it. Incorporated the company in July 2020, started kind of fundraising, not entirely sure what we were doing, but put together a pitch deck, very similar to how you might put together like a research presentation. It was a very scientific pitch deck, not a very businessy pitch deck. But yeah, we found a couple venture capital investors who were really more interested in investing in founders, not like a company, So that was such a lucky, serendipitous event to meet those kind of VC people who saw in Alex and I. They realized, like, you're gonna figure this out. You guys got PhDs, you figured out this technology, you can figure out the business side. And that's what we've been doing ever since.
I love that. I want to get back to this founder-led biotech idea, but before we get to that, how did it work as far as reaching out to investors? Were you guys cold emailing people?
Oh, yeah.
Did you work with anybody as far as crafting the pitch deck? And also, like, was your network that you'd already built involved in like connecting with these investors?
Yeah, really great questions. So Alex last summer took one of these I-Corps summer programs. So the University of Washington and I forget how many, maybe like 13 or 16 other universities around America have these National Science Foundation, NSF sponsored programs that are exactly geared towards these technical founders, these scientist founders. So you've got some like cool inventions, some cool technology, and you got to figure out like what are the next steps. These programs are great. So he went through this program. It helped put together like a draft pitch deck. It helped kind of put together some semblance of an idea of a business model, and some of the basics of business development. So that program was really very helpful. It had some contacts to VC, but really the majority of that pre-seed round of funding was just cold email, cold call, and attach a draft of the pitch deck or a short like 1 or 2 pager about the company, and yeah, hope that someone gets back to you and you can do a deeper dive.
Awesome. And so when you did end up having those meetings with these potential investors, how did it work? Like the two of you on Zoom with them? I mean, because this was all during the pandemic, obviously.
Yeah, fundraising, incorporating the company, fundraising, and doing everything entirely in the pandemic was really weird. Like Alex and I didn't even see each other again in person, face to face, for like a year after we started the company. It was all Zoom. There's pros and cons to that though, right? Like one of the pros is you can kind of fit in a lot more meetings when you're doing it virtually, just because you can stack like your entire day. You don't have to travel, and you can just do all of these back to back to back 15, 20, 30-minute initial calls. So most of these kind of venture capital pre-seed funding calls, the way it goes is Alex is the CEO. So CEO, he is usually the first one to reach out, send an email. If they like it, they'll do like a real quick kind of litmus test. Just, do we want to talk more, or are we going to pass? So he usually takes those. And then the second call, if they decide that they want to maybe think about investing, that's when I get on the call too, as the CTO, technology officer. And they're looking for a couple things, right? A little bit, it's like when you get your PhD and like you get grilled by either your thesis committee or you go to a scientific conference and they kind of grill you after you present. It's a little bit of that. And in part, it might not actually be a real question, right? The VC might actually just be seeing, can you come up with an answer? Can you figure out how you would find the answer? If you don't know the answer, are you going to like BS me and just make something up, or are you just going to be very honest about it? And then the other thing VC are looking for, not just kind of that technical, like what is your company built on a solid foundation, but they're also looking at you two as founders, like you and your co-founders. They're seeing, how are you interacting with each other? Is this seem like you two are going to be able to work together, even if like everything's on fire, like the whole lab's on fire. Are you guys still going to be working towards it together? Or are you gonna cut and run as soon as you can? So those calls can be very intimidating, because they're really grilling you with a lot of questions because they want to make sure they're investing in something they believe in. But they're also a little bit fun because if you do truly like feel comfortable with what you're doing and you understand it very well, it's kind of a chance to brag, be like, oh, that's a great question. We totally thought about that too. Here's how.
Nice. Along the lines of founder dynamics and how investors make decisions on founder-led teams, how did the conversation go as far as CEO versus CTO? And do you think there's anything about your relationship with Alex that really makes things flow and makes people want to invest in you as a team?
Yeah, I definitely 100% not only think, but know that that is true. So as far as deciding who was going to be CEO and who was going to be like a CTO or a CSO, I was way more interested in kind of like the science in the lab, way more than I was about, like the finances or the accounting. Like I wanted a place to do cool science and take this technology in a direction that would be useful, right? Like a technology that's not useful is not really worth working on, and it's not worth having a company around. So there was absolutely no debate over who would be what kind of role, and we've kind of tried to divide up a lot of the responsibilities so that they kind of fell into those two areas. So a lot of kind of like the science or the technology questions get directed towards me, and a lot of kind of the business and corporate questions, he'll tend to take those. And I think this works really well for the two of us. One of the reasons I was totally on board with launching this company, especially with Alex, is because when we were working together on this collaboration and doing the original project that came up with this technology, that invented this technology, there are some people that you work with that are just so much fun to work with. You can be in the lab from 7 a.m. to like midnight and then still want to go out and get a beer with them. Like you just totally click. You speak the same kind of scientific language. You know exactly like what the other person might be thinking about, and you kind of have a complement of skills and expertise. So it was one of those things. I had been working in another lab. I realized how rare it is to find a coworker, a colleague with that kind of vibe. So when he reached out, I was like, yes, 1,000 times yes. Even just to work with him again was going to be a lot of fun, and we would figure out what to do after that.
Nice. That's awesome. I want to go back in time a little bit to graduate school for you and what led you to want to pursue a PhD and that process of deciding which program to enter and which lab to enter.
Oh my gosh. Yeah, I will preface by saying if you asked me as an undergrad what I was going to do, it was not science. So I had gone into science originally because I was really wanted to take part in the disease research and therapeutics and curing disease. There was a little boy that I had like seen on TV. His name was Matty Stepanek. He had a muscular dystrophy, and he's sadly since passed away. But it seemed like the perfect time in my very early education. I was in high school, and we had just, you learn about cells and organelles and like mitochondria, and this little boy had a mitochondrial disease. So it was just like, oh my gosh, like the things I'm learning in school can be applied to help people. I think it was the first time I had made that kind of connection. And that's what got me going down the path towards molecular biology. I did a summer nerd camp in high school where it was like voluntary summer school, and I dove a little deeper into biochemistry and molecular biology. I decided this is what I wanted to do. I looked for undergraduate programs that would be specifically in biochemistry or molecular biology. There weren't too many programs. It was usually either like you could go to chemistry with like a biology option, or like you go to biology and get kind of like a chemistry minor or something. So I finally found a program that did biochemistry and molecular biology. Signed up, wanted to start doing undergrad research, found a lab that was working in mitochondria, because remember, that was what had kind of like set this whole thing into motion. Found a lab doing mitochondrial research, and it wasn't a good fit for me. That lab, the way the lab ran, wasn't a great fit for me, and I actually decided I was going to leave science for a while. So I
Wow.
left science. Yeah, it was one of those things that I was like, I don't know if I want to do this for the rest of my life. Kind of the next steps after undergrad are to go to grad school, and
Yeah.
then after grad school is to go to a lab. And I was like, oh man, I guess this isn't cut out for me, because I did not enjoy this lab experience.
When you say it wasn't a good fit, can you elaborate on that a little bit?
I loved all the science, but for me, I am not a great book learner. I don't learn by reading things. I don't learn by watching things. I learn by doing things. And in this particular lab, I didn't really get the chance, the way that mentorship, mentee mentor relationship was. I didn't really get the chance to just sit at the bench and try something, right? It was kind of, everything was very by the book, like memorizing textbook equations, and kind of working backwards that way. So I was kind of like, oh man, if all science is like this, I'm definitely not going to be good at this.
So you were about to say after undergrad, you decided maybe this isn't for me. What changed?
Yeah, so well, I ran away for a couple of years. I moved to South Korea, and I lived in South Korea for 2 years on a Fulbright English teaching assistant grant.
Wow.
So yeah, yeah, I was like, science, clearly I must not be a good scientist, but what about teaching? So
Do
I
you
wanted
speak
to,
Korean?
a little conversational
Oh,
Korean.
nice.
Yeah, yeah. And it was a really great experience. I kind of lived not in Seoul, not in one of the big cities. I lived
Hmm.
out in the countryside. I lived with a homestay family. It was a fantastic experience. I really loved teaching. I found it really rewarding, teaching English to these students, and we kind of lived in the middle of some rice fields. The town I was in is famous for two things: a strawberry festival and an army boot camp base. So really not a lot going on in the area. And I found it really rewarding when the students that I was tutoring, that I was teaching, would score high enough on their English exams that they would be accepted to American or Western universities. Like, that was just so rewarding. Um, as rewarding as it was, I super missed science. Um, Regardless of how my experience in undergrad was, I missed science. So I came back after 2 years in Korea, applied for jobs. It was a difficult time. It was a lot of job applications. I had been out of science for 2 years straight after undergrad. So I was very lucky that a hiring manager decided to take a chance on me. And I started working at the Broad Institute in their genomics platform. I lasted about 6 months before I was getting a little frustrated with that job. Um, it was a lot of it was just processing samples, right? Like, all these different kinds of DNA samples coming in, and my job was to put stickers on them. I put the barcode stickers on the samples. So I was like, oh man, I definitely love science, but this is not quite what I was thinking. So I took my resume and I started shopping it around other labs in Boston, and a lot of them were not interested. They were looking for fresh out of undergrad, like planning to go to grad school, to med school. I didn't think I wanted to go to grad school at the time. I liked doing kind of lab tech work. Um, Finally got lucky, and someone was looking for a position, and I was able to get recommended for this position. She told me, as soon as I sat down with her at this interview, this like coffee interview, she told me my resume was awful. And the only reason she was talking to me was because I came recommended from someone she knew personally.
Wow.
So
What
like,
what
oh
year
man.
was this, if you don't mind me
Oh yeah,
asking?
this was so I graduated my undergrad and I moved abroad to Korea from 2009 to 2011.
Okay.
I was in Korea. So I came back 2011, uh, decided I wanted to change my lab tech job in 2012.
Okay.
So this was
Okay.
2012. I was lucky to get this sit down. She liked me as a person. She hated my resume, but she took a chance on me. And for 2 years, I worked with her, and it was fantastic. I fell in love with what I was doing. It was the mentorship fit that worked perfect for me. She let me just go in the lab, and if I was going to mess up, and she knew it, she let me mess up. It was a lesson learned. If I was going to electrocute myself with the instrument, she was just going to, you'll learn not to do that again. So,
Really?
yeah, it
Did
was
you
it
do
was
that?
only a little bit. Yeah, we were working on hardware for mass spectrometry, and it was kind of experimental hardware. So there were some lessons learned there. Um,
Wow.
a lot of lessons learned, but that was exactly how I needed to learn.
Yeah,
I could have read it 50 times and it would have never clicked for me if I didn't do it myself. I
sure.
needed to like process those samples. I needed to work with the instrument with my hands. And I totally fell in love with that area, this mass spectrometry, proteomics field. And that is when I decided I was going to go to grad school. So it was
Wow.
a long path. And I really, really was resistant to the idea of going to grad school until I decided I absolutely love what I'm doing and I want to do it for the rest of my life. And I committed to going to grad school. So I already knew the PI I wanted to work with. I knew the professor I wanted to work with because I had been in that field for a couple of years now. And you read papers after a couple of years, you go to conferences,
Hmm.
you start talking, and I was like, oh man, this is the skill set
Yeah.
that I want to
Wow.
gain.
So you went into grad school already having a PI in mind that you wanted to work with, which is
Yep.
kind of a unique experience, I would say, in this day
Yeah.
and age with how things go.
Yeah, I think it's definitely a little bit backwards. And I did debate a little bit what kind of PhD I got. I thought it really mattered what the name of the PhD would be. A PhD in chemistry um, is what most people doing mass spectrometry proteomics would get. And this was going to be a PhD in genome sciences. And I was just like, oh, people are going to read PhD in genome sciences and they're going to think I'm one way when I'm actually another way. And it took a mentor to like sit me down and be like, nobody is going to read the title of your PhD degree. They're going to read the titles of your papers. They're going to read the title of your thesis. Don't worry about it. So piece of advice that I'm glad I got when I did. It
Yeah,
definitely influenced my decision.
absolutely. So how many schools or programs did you apply to?
I ended up applying to 5 schools or 4 schools, 5 departments, 5 programs. And I flew to 4 of those. One of them I was able to eliminate pretty quickly after I got acceptances from the others. It was kind of like a safety school. I flew to the other 4 for the kind of like recruitment weekend that they do after you apply to grad school. If they are interested in you, they'll fly you out and you get to kind of see the campus, see the department, see some of the professors. So it was at that stage I was able to narrow it down to 2 programs. They were both at the same school because I fell in love with Seattle. Both of these programs were at the University of Washington, and I just really fell in love with Seattle. And I knew that's where I wanted to be for 5, 6, 7, 10 years, however long it took to get a PhD. And it was coming down to the choice, which program, a chemistry department or this genome sciences department.
And so how did you decide?
Yeah, it came down to I had PIs in both programs that I was really interested in. And it came down to one of the skills I really wanted to gain if I was going to take this time to get a PhD versus, for example, I could have gotten a master's part-time while I worked in Boston. I figured if I was going to take this time out and go back to school, I really wanted to gain these coding skills. Big data, like when I was at the Broad as a research associate, I just really saw that big data was the thing, right? Like data sets were getting bigger and bigger. The people who got to do some really cool analyses all had coding skills. And I knew that's what I wanted to do. So it came down to the genome sciences department really emphasized gaining coding and statistics skills. So that was it. That was the decision. And I signed up even though I absolutely had no idea a year previously that I would not be doing a chemistry PhD. So that was the only not chemistry program I applied to, and it's the one that I ended up going with.
Nice. So you come into genome sciences at University of Washington. The program is set up, you have what, 3 or 4 lab rotations your first year to help you decide where you want to spend the rest of your graduate school time in. But you had already kind of had a mentor picked out. So how did that go as far as your rotations, and walk us through that process?
Yeah, so the rotations were fantastic, and I'm so glad the department did rotations. It's not really something that a lot of chemistry departments do. And my rotations, the very first one, I was like, I'm going to work with the guy that I came here for. The second one was an area I was interested in, protein-protein interactions, but I didn't have any experience in. So I was curious to try that. And then the third one was computational, entirely dry lab computational. I ended up like falling in love with all 3 of them, but you can't have 3 PIs usually. However, you can have 2 PIs. So I actually ended up being joint advised. I couldn't decide. The guy I originally went there with ended up becoming kind of my main lab, but I was co-advised, joint advised by a statistics and machine learning lab as well. Kind of decided if I was going to gain these skills, I would gain them the same way I gained skills in Korean language, which is just go straight in the deep end, right? Like no training wheels, just total learning by full immersion.
Absolutely. And who were the PIs, if you don't mind naming them?
So these were Mike Koss. So he's was a really big name in mass spectrometry proteomics and was starting to get into this idea of going high throughput. So really big data mass spectrometry proteomics. So that lined up exactly with the kind of things that I wanted to learn. And then my second PI was Bill Noble. So he had also put out some really high profile papers on statistical analysis and machine learning for big proteomics data. So it was kind of like perfectly the skill set that I wanted to gain while I was in grad school.
Nice. I was actually I had co-advisors as well in graduate school. So
yeah, there's pros and cons. I like one of the cons is it's hard enough to make one advisor happy. It's twice as hard to make 2 advisors happy all the time. But it's also just really great to get kind of a unique experience, I would say, by getting training from 2 people. So absolutely. I did like it a lot.
Yeah, and I think it's helpful, like in my case, one was pretty hands-off and the other one was younger and, you know, more involved. So it was a good balance in that regard.
For sure.
Mike Koss has kind of an interesting career story as well. Did you connect with that at all? Like as far as why you were kind of excited to work with this person? And do you want to share a bit of his background?
Yeah. So Mike Koss comes from a very like a highly academic kind of famous scientific family. So that was not something that I shared in common. I was the first in my family to get a PhD. But one of the things that really stood out to me about Mike is very early on when he was a professor, he wanted to build a software that everyone could use that would kind of unify and harmonize everybody's science. This was not something that existed in mass spectrometry proteomics. You were very siloed by what brand of instrument you happen to use. And that really inhibited a lot of these big data kind of projects because you'd have to get everybody to buy the exact same brand of instrument. And that just seemed very silly. You should be able to like do the best data on the best instrument that you have available to you. And he created this software, the Skyline ecosystem, the Skyline software suite. And not only he made the software, he hired like real software engineers to do it. Like he got guys from Microsoft in Seattle to come over and work on this project, Brendan McLean. So it was not some like kind of academic piece of software that was a little clunky and maybe a little sad to use. It was a polished, usable like tool that really enabled a lot of mass spectrometry in the last like decade, since it's really become a big thing. And that really resonated with me, and that is how I learned about him, was using this software. And that's what led me to think, this is the future of the field. The future of the field is bringing labs together, not siloing everybody's data separately. That's what made me decide to go work with him.
Nice. So now that you are a co-founder of a company, looking back at your time in grad school, did you see this in your future at all? And if not, you know, what kind of steps do you think helped get you to this point?
Yeah, I had zero idea at any point up until like the minute Alex called me last year. He didn't even tell me what he was calling about. He was just like, hey, can I call you? It was just like out of the blue. Like, can we talk? It's like, I hope you're okay. When I was in grad school, I started grad school thinking I wanted to go straight to industry. I wanted a PhD, but then I wanted to go to industry or like a nonprofit, like the Broad or like Fred Hutch, work somewhere nonprofit kind of a thing. About halfway through my PhD, people had just started telling me like, you're a really good teacher, you're a really good mentor, you would be a really good professor. You should like start your own lab and like be a professor and go tenure track. So I was like, okay, like I do like teaching. I had that whole like Korea thing, teaching English. That was a lot of fun. It would be pretty cool to like do science and also do teaching at the same time. So that's why I decided, after I defended, that's why I went out and did a postdoc. That's kind of what you do if you want to go tenure track. You do a postdoc for an indeterminate number of years until you get lucky enough to land a tenure track position. So I started my postdoc, and 6 months later, the pandemic hit. So the postdoc just kind of like fizzled out pretty quickly with all the lab shutdowns. And while it was fizzling, that's when Alex reached out. He was like, so what would you think about starting a company around this idea that we had worked on when you were in Seattle? And I was like, have my own lab, work on something I love doing, and work with people I love working with. Yeah, that sounds pretty awesome. So yeah, grad school, I would have never thought this would be the path. Even just, you know, a year and a half ago, I would have never thought this would be the path.
Wow. And so how big is the team now?
Yeah, so we have a small team. We're still under 10, but we've got a couple of fantastic research associates that have been with us all summer since we kind of opened the lab, and they're doing fantastic. Like, I remember back to when I was a research associate, and it's just like, oh man, like it was stressful those first like 3 or 4 months when you're in a new lab, learning a new skill set, and they are just absolutely rocking it. We have a data analyst who started with us as a consultant, and we just loved him so much we wanted to keep him. So we convinced him to stay on with us. And then, kind of borrowing from how Alex and I as founders came back together, I reached out to someone I had worked with in Bill Noble's lab. So a kind of computational proteomics machine learning expert, and loved his work, loved working with him, wanted to make that a thing again. So we convinced him to join the team as well. And we have our latest addition is from the laboratory that I had debated about whether I wanted to join that chemistry lab or that genome sciences lab. So I took one of the chemistry lab's latest PhDs, and he's now our latest hire, mass spectrometry proteomicist. It's been a lot of fun to build a team that you just enjoy working with, where yeah, like there's a 9 to 5 job, but it like one of the research associates decided this past weekend she had a scientific question, she wanted to ask it, she went into the lab, she worked all weekend because she was just like so driven to ask this question. It's just like trying to keep that kind of culture going is so important to me, to make sure people have space to love science, to love what they are doing, because that was what finally led me to where I am, was someone finally giving me the chance and the space to do science and fall in love with it.
Absolutely. It sounds like you guys have had a pretty good experience so far as hiring, despite it being a relatively competitive environment. Is that
It is very competitive, and these are the people that we've hired now, but there's definitely positions that we've been trying to fill that are just so hard to fill. Like biotech is booming right now, and that is both great and awful. It's great because it means a lot of venture capital is paying attention to the biotech industry, right? A lot of venture capital over the past 2 years now have a lot of reason to think like maybe there is a lot of value out there in biotech. So they're paying more attention to these cold emails, these cold calls. They're maybe opening them a little bit more often than they used to. They're maybe taking more of these calls, these deep dive calls, and they're writing more checks than they used to. On the flip side, though, because biotech is booming, it is so hard to find good people. Like there is just so many opportunities out there. So many people are hiring. And I mean, I would brag a little about my field. I feel like proteomics in particular is just taking off. There are so many companies these days that are doing protein work in some capacity. So having skills in proteomics is very, very high demand, very
Yeah,
competitive.
absolutely. I'll speak for myself. We've had this computational biology position open for forever, and we've, kind of unfortunately lost several candidates now to other companies. And it's just like, oh my God, when are we going to find somebody to fill this position? So I wanted to give you a second, if there are any open positions, if you want to talk about them
Yes.
briefly on the podcast.
Yeah, we are very, very interested in hiring some medicinal chemists. And this could be anyone from medicinal chemistry, like straight out of your PhD, or all the way up to someone who would want to be a role like a director of our medchem program. We're really looking for that kind of position right now. So if you've got some medchem background, reach out to us. Website's talus.bio. Hit us
Awesome.
up.
Yeah, I'll definitely put the link below as well. And is there like a careers page on the website
Yes.
for, okay, nice.
Yep. Yeah.
So I want to get back to this idea of founder-led biotechs, because there was a recent tweet and article, which I'll cite at some point, about the rise of founder-led biotechs and how there's been this kind of shift in these companies. Would you agree with that observation? And have you found any kind of community amongst these founder-led biotechs, or has it been a challenge operating in this pandemic environment?
Yeah, I would say an inclusive yes to all of those. There is, I think there has been a real increase in founder-led bio companies, and in particular kind of younger founder-led bio companies. So kind of the traditional model with Boston or Cambridge pharmaceutical investment is that they tend to invest in companies that have a scientific advisory board or a board of directors that includes a bunch of retired pharmaceutical executives. So if you're a younger, like fresh out of your PhD, fresh out of your postdoc, spin out from university, it can be very difficult in the past to get funding to do that. I think that's kind of changing, because I think a lot of, the younger Silicon Valley style money is realizing the value in biotech, and they're willing to take a chance on you as more of a person rather than you as your company as it exists right now on paper. So there's becoming a lot of kind of accelerator programs. There's that I-Corp program that I mentioned with NSF that are trying to give PhDs and postdocs the business side of it that you don't get while you're doing your science. I think those are becoming big. As far as kind of finding a community, we have had good luck finding community in these scientist founders with local kind of support groups. So in Washington State, there's a life sciences research group specifically for startups and in the life sciences space. And they offer mentorship programs, they offer community, they offer kind of seminars and events and networking. So those are really great. And then there's also these larger accelerator programs like Y Combinator or Indie Bio or Creative Destruction. And these accelerators also kind of give you a community of other founders probably going through the exact same things, mistakes that you're going through, and you can all learn from one another. So it's the downside of the pandemic is that these things have not been in person, but the upside is you can do them from wherever, right? Sometimes accelerators are difficult when you have a life sciences lab because you have to have a lab space. But with everything being remote, it kind of opens up more opportunities to go to these accelerators or these networking events without having to physically move your entire laboratory to a different state or a different city.
Sure. Has it been hard to find lab space for the company?
Yeah, these days lab space is so hard to find because biotech is booming. I know, especially in Boston and Cambridge, it's like kind of the heart of biotech from a pharmaceutical standpoint. Super hard to find lab space there. We even have trouble in Seattle finding lab space. They're booked out until 2022, 2023. A lot of cities are building new laboratory space because they have also figured out biotech is booming and they want to get in on that, but it's still under construction. So it's tough to find just a physical bench to do work at.
Do you see any downsides to the biotech boom aside from the lab space shortage?
Yeah, I think this is going to definitely come down to kind of the community. So this could go two ways, right? Like biotech is booming. Either we as kind of an industry, as a community, prove that there is value in these things, and it continues going well, or too many of these companies aren't built on really solid science, right? They're not built on a real actual technology or approach or idea, and they go bust. And I think if that happens too often, we won't get those investments. We won't get those communities building more lab spaces for us. So I think it's kind of, it'll be very interesting in the next 5 to 10 years to see how that's going, because so far the momentum has all been that first one. So far the momentum has for the most part been biotech is great, you'll definitely see value added, you just got to kind of avoid over promising and under delivering kind of a thing.
Absolutely. On that note, do you have any advice for folks starting out on their journey as far as founding a biotech, or maybe they've recently started a company?
Yeah, I mean, if you are in grad school or you're a research associate somewhere and you've got a really cool idea, go to your institute, and they almost definitely have some sort of like innovation center or spin out center or like intellectual property center. Go there and tell them about it. If it really is a cool idea, they're going to help you write the patent to protect it. Once you have it patented, you kind of given a really large runway once you kind of have those boxes checked. But it's a really good sounding board, just like, is my idea crazy? If you have one of these I-Corp or kind of like educational programs, go check that out. If you have an MBA program at your school, go drop in on a couple of those classes, take or audit a couple of those classes and get an idea about the business side. A lot of PhD programs or master's programs don't really talk about those things. You kind of have to seek them out yourself, but they probably exist at your institution and you just haven't heard about them yet.
That's great advice. I think when you're within an institution like a university, they really do have so many resources for folks, and it's a great time to take advantage of those options. So awesome. Well, I think that wraps up the questions I had for you, Lindsay. I have learned so much, and I just want to thank you for taking the time to chat with us about your experience with Talus Bio. I'll make sure to include the link for your careers page, and I'm just excited to see what happens with the company and hear from you and Alex hopefully down the road about how things are going. So thank you.
Yeah, thank you so much too. And if anybody has other questions or you want to reach out, feel free, hit me up. I'm on Twitter. I have a site with my contact information. Yeah, would love to chat more about any of these topics.
Awesome. Thank you so much. And I'll
Thank
make
you
sure to
too.
put all the links and everything, and for your Twitter, any other social media that you want. So
Yeah, perfect. Any questions from grad school to startups, anything in between? If you want to go do a Fulbright, we could talk about that too.
yeah, very interesting. I didn't know that about you. That's awesome. Those are hard
Yeah.
to get too, I think.
Yeah, mine was a little bit easier because it was like the English teaching one, and less
Okay,
people wanted an English teaching one. I wanted to like see if teaching was a thing. Maybe science wasn't my thing. Turns out
interesting.
it was my thing.
Do you think you'd ever go back to teaching?
Um, I do really enjoy teaching, and I still do a lot of teaching on the side. So that software, that Skyline software suite, I do tons of workshops teaching people how to
Oh,
use that and how to do quantitative proteomics. So
oh, okay.
still super love teaching.
That's great. I love that. Awesome. Well, I'm gonna let you go, and you'll get an email probably in like a week-ish with the edited, first edit version, and we can go from there.
Yeah, that sounds awesome. Thanks so much. This was fun.
Yeah, thank you. Talk to you
All right.
soon.
Bye.
Bye. That wraps up my interview with Lindsay Pino, founder of Talus Bio. I learned a ton from that conversation, and I hope you guys did too. If you're interested in hearing some more stories from female founders in the biotech space, I recommend you go check out the interview I did with Dr. Christina Trojdal Hansen. That's another really good one. I'll be featuring several more female founders in the coming months on the podcast, so stay tuned for those episodes. Make sure you subscribe and leave us a review wherever you listen to podcasts. Thank you so much for supporting our show.